Okay, so just like any stoichiometric problem, you want to know what you're starting with, you want to know what you're finishing with, okay? That's just something that you're going to have to use pretty much all the time. So let's go ahead and figure out what we're starting with on number 18. So the question says a 9.168 molar aqueous solution of H2SO4 has a density of that, what it says, at 20 degrees Celsius. How many grams of H2SO4 are in 50 grams of this solution? Okay, so right off the bat, what you want to analyze the information that you're given, okay, always, because sometimes they may give you superfluous information and you may use it, you may not use it, or you may use it later, okay? So it's important that you guys understand what you are going to use right away, what you're not going to use right away, and what you're not going to use at all, okay? Sometimes a problem may give you some information that you don't need. So like in this example here, it gives you density, okay? Now, I'm not going to tell you guys right away if we would need to use it, okay, but let's always start by knowing what we have and what we need to get to, okay? So let's figure out what we're starting with and what we're going to finish with. Okay, so we know that we're starting with basically a 9.168 molar aqueous solution of H2SO4, okay? And we want to know how many grams of H2SO4 are in 50 grams of the solution. So we have 50 grams of H2SO4 solution, okay? And you can add the molarity later on, but you want to know how many grams of H2SO4 are in it, okay? So question mark, grams of H2SO4, so the solute, okay? So you have to figure out a way to get from here to here, okay? So we're starting with just the 50 grams of the solution, and I'm gonna put that for solution, SOLN, and we want to get to X grams of H2SO4, okay? Let me just double check who's here. It's just us three right now, okay? How many grams of H2SO4, the solute, so just the thing that's dissolved in the liquid, okay? So to go ahead and do this, we're gonna have to use a couple of different things. The first thing we're gonna need to know is molarity, always, okay? So for problems like this, and someone just joined, can you let me know who just joined? So I can, never mind, I got it. Okay, Brian, what's up, Brian? Okay, so there, I wrote down the concentration, right? You have molarity is moles of solute over liters of solution. Let me just write your names down, okay?
Matthew's trying to join, but I think his computer's like acting weird.
Okay. Well, if he wants to look on with you, that's okay, as long as you just let me know that he's there with you, okay?
Yeah.
All right.
Matt, is it working still? Yeah, he's trying to connect.
Okay, so let me know, and if not, then he could just look on with you and I'll write his name down.
Alrighty.
All right, so here your concentration. Keep all of these equations like close by, all right? I like to write them all down in note cards for when you take your test, so that you have basically all the information that you need close by. Let me move myself here. Okay, so you have your concentration. Molarity is moles of solute over liters of solution. Which one of these do you think we're going to have to use for this one if we're trying to find the grams of H2SO4? And we start with the grams of solution. Which one of these has solution in it? I'm just going to go ahead and tell you guys, it's going to be molarity. So you're going to use molarity for this one, okay? And that's what's going to help you get from 50 grams of the solution to the grams of the H2SO4, okay? So the first thing that we want to do is we want to convert this into something that's usable in molarity, okay? So is that, okay, that's Matthew, awesome. Hey, Matt. We want to be able to convert this into something that's usable with molarity, okay? So here we have the solution, right? But we have grams. We're starting with grams of solution, whereas in the molarity equation or formula, sorry, you don't have grams of solution, you have liters of solution. So the first thing we need to do is convert grams to liters. Now, how in the world are we going to do that? There's a pretty simple way to do it, and that's by using the thing that they gave us, okay? The other thing that they gave us in this problem was density, okay? Density is kind of this like weird P equals mass, and I'll just go ahead and write that there, mass over volume, okay? And you can pretty much decide what you're gonna use. Most of the time is grams per liter, all right? And that's probably what we're gonna wanna use, okay? Grams per liter, so that we can convert then this 50 grams of solution to liters of solution, okay? All right, so it gives us the density. Let's go ahead and let's go with step one. So the first step that we're gonna have to use here is to convert the grams of solution to liters of solution. Okay, and I'm gonna take this problem step by step. Okay, I'm gonna like do each step in its own bridge notation. If you know what you have to do, you know the steps from beginning to end, then you can just make like one big bridge. Okay, but I'm gonna go ahead and can you guys still hear me? Are we good? Because it says that my internet connection is weird.
Okay. Yeah. You're good.
All right.
I hear you.
Just so you know, let's say that this shuts off. I'll go ahead and I'll like try to fix it, and I'll repost the link, okay? And I'll send the message on Edmodo, just so you guys know, just in case something happens, okay?
All right.
So we have the grams of solution. We want to go into liters of solution, okay? So let's make a bridge for it. And the way that we're going to have to figure this out is by using the density. Now, the density that they gave us, what's the density that they give us in number 18? It's 1.4987. 0.4987. And this is important. The units, I keep losing it, grams per milliliter. Grams per milliliter, okay? But just so you know, we're gonna use the density and we need to get the liters of solution. So we're gonna have to do something else to convert milliliters to liters, okay? All right, so if we have 1.498 grams per milliliters, what we have to do is first, let's start off with what we start with, right? Which is the 50 grams of solution. All right, I don't know if this is gonna work. Oh, perfect, okay. So we're gonna start with the 50 grams of H2SO4 solution, all right, over 1. Okay, basic stoichiometry, we always put the first thing over 1. Now, what is our conversion factor? We want to go from grams, we want to get rid of this grams, right? And what do we want to turn it into? What's the next step according to what I wrote here? We want to go from grams of solution to, what is this? Liters. Liters, yes, good. Liters of solution. So we're going to have to use this conversion right here, okay? And we want to go ahead and eliminate grams. This right here basically tells us that it's a conversion factor, right? And it tells us that 1.4987 grams of H2SO4 is dissolved in 1 milliliter of H2SO4. So this is a conversion factor that we can use and we can put in here. So to be able to eliminate grams, I have to put grams on the bottom, correct? Okay, and this is according to the solution. So if I have 1.4987 grams of H2SO4 solution, okay, sorry. Let me make this bigger here. All right. Now here I can eliminate that. Okay. I can eliminate that grams of solution. And basically this 1.4987 grams of H2SO4 solution is dissolved in 1 milliliter of H2SO4 solution. Okay. Density is just mass over volume, right? And we write the units here just to make it easier for us, okay? But normally, since the units are the same on the top as they are on the bottom, you would just cancel out this H2SO4 solution. That's why with density, we don't like write out the whole thing. We just write out the number and the unit, okay? So in this case here, now we're able to cancel this out, but we're going to leave that to the end. What are we going to finish with so far, with what we have so far? We're going to finish with milliliters, right? Because the grams of H2SO4 solution are going to cancel out. So we don't want milliliters. We want liters, right? So can someone tell me what conversion factor I'm going to have to use now to go from milliliters to liters? What's the next step? What do you guys think? Someone? Anyone?
Don't you have to put like 1,000?
Yeah, exactly. Okay. Basically, that 1 liter of anything, okay, is going to be 1,000 milliliters. Okay. And we don't even have to write the units on there. Okay. Good. So now let's check if we're starting with what we're supposed to start with and we're finishing with what we're supposed to finish with. Okay. All right. So we start with 50 grams of H2SO4, right? And we want to finish with the liters. So that is correct. Now let's make sure that everything can cancel out. So we have grams of H2SO4 solution, grams of H2SO4 solution, milliliters of H2SO4 solution, milliliters of H2SO4 solution. I just didn't write it out. So we're going to finish with liters. Okay. And that's exactly what we want. So in this case, we did use the density. And Brian and Matthew, what I was telling Camille and David is that sometimes a problem will give you extra information that you won't even use. Okay, so you have to always, always, always know what you're starting with and know what you're finishing with. So you know if, like, let's say they gave us density, right? But sometimes they'll just tell you random stuff, right? That like you don't even need. In this case, we did need to use density, okay? But always know what you're starting with, know what you're finishing with, just like when we were doing stoichiometry, okay? All right, so now we have liters of solution. Let's go ahead and just use our calculators to figure this out. And please be doing this with me as I'm doing it. So I have 50 divided by 1.4987 divided by 1,000. Okay, and I go ahead and I work that out and I get 0.0333 6.2, and I think that's enough. 6.2 what? Liters of H2SO4 solution. Okay, so that's what I have so far. Is that what I'm supposed to finish with? No, what am I supposed to finish with?
Grams.
Grams of H2O4 solution, exactly, okay? Now, I wanna finish with grams of H2SO4 solution, right? To be able, no, sorry, not grams of H2SO4 solution. No, not grams of H2, because that's what we started with, right? We started with grams of H2SO4. We just want to know the grams of H2SO4, okay? Not solution, not solution, okay? We want to know the solute, all right? The solute, the actual H2SO4 that's dissolved. For that, we're going to need to use molarity, okay? We want to finish with the grams of H2SO4. Is there some way to measure, think about it. If I have like a cup, okay? I have a cup and this cup is filled with H2SO4 solution, right? Sulfuric acid solution, that's what it is. Sulfuric acid solution, right? That means that sulfuric acid is dissolved in this cup. Is there a way to measure the grams of just the H2SO4? Like, can I put this on a balance and measure the grams of only the H2SO4? Would that be possible?
No.
No, right? Because it's dissolved in the water. The water's mass is going to affect it as well, okay? That's why we need to use this right here, molarity. And what molarity will do is if we know the concentration, okay, we already know the liters of solution, right? We know the molarity. What's the only thing that's missing in that equation? They gave us the molarity, right? Let's go ahead and let's write out the molarity. Actually, that's probably pretty important to do. What's the molarity that they give us in the beginning there? It's 9.168, okay? Molarity, and remember that molarity is moles per liter, okay? Moles of solute per liter of solution, all right? We know molarity of this solution, right? We know the liters of this solution. So if we use this formula, we can find the moles of the solution. Now, is moles what we want at the end?
No.
No. What do we want at the end?
Grams.
Grams of H2SO4.
Exactly. But if I know the amount of moles of H2SO4, is there a way that I can figure out the amount of grams that correspond to those moles of H2SO4? Is there a way to do that? What do you guys think? If I know the moles of something, can I figure out the grams of that? Yes? No? Who thinks yes?
Yes.
Yes? Yes.
Yes.
What do we use? What do we use to figure that out?
Avogadro's number.
No, that's to figure out the atoms in it. What do we use to figure out?
Molar mass.
Molar mass, exactly, right? It's like in the name, right? Molar mass. If we know the moles, we can know the mass of those moles, right? Molar mass, okay? Perfect. So the next step, guys, is going to be, we know we want to get here. So we had 2 steps that we had to go into here, right? Step 1 was to figure out the liters of the solution. And then step 2 was to figure out the moles of the solute. Okay, and then finally at the end, we're gonna, step 3 was to finish with the grams of the solute. Okay, so next step right now, let's go ahead and let's move on. And I know that this problem is taking a pretty long time, but if you know how to do this problem, it'll help you like pretty much get all the other problems, okay? So we know, sorry, 1 second. Can you turn on the air, please? Thank you. We know that we have this many liters of the solution, right? Now let's use molarity, okay? Let's use molarity to try to figure out what the moles of the solute are going to be. Okay, now this one, we can put it in a bridge notation, but it probably works a little bit easier. It's probably a little bit easier if we just go ahead and write out, if we write out the equation. So we have moles of solute over liters of solution, okay? Now, what do we know? We know liters of solution, right? So let's go ahead and just go like this. We know 33362 liters of H2SO4 solution, right? We know the molarity. What's the molarity? What's the molarity? Did they give us the molarity?
No.
It's right here, right?
Oh,
they give,
yeah.
that's the first thing they give you in the problem, right? A 9.168 molar aqueous solution. So here we have 9.168, right? Moles, molar, right? Okay. And then do we know the moles? Do we know the moles? No, we do not. So I'm going to make that X. Okay. We don't know moles. Now, basic algebra. If we want to isolate the moles, what are we going to have to do? What do we have to do? Multiply by what? By this, right? To be able to get an X by itself, we have to multiply by what's in the denominator. So multiply by 0.33362 liters. That's going to cancel out. Whatever you do to one side in math, you have to do to the other, okay? And that's, let's see, 0.33362 liters. Let's go ahead and multiply that, okay? And when we multiply that, what do we get when we multiply this? Let's see, we have, it was probably better to do it in one of these. Whatever, it's okay. So when we multiply that, we'll get 0.33362 liters of H2SO4 solution. I'm going to write out the whole entire thing, okay? Times 9.168 molar SO4 solution. Now, what does that mean? That means moles of H2SO4 over liters of H2SO4 solution. Okay, and I'll tell you why it's important that we wrote that out, equals X moles of H2SO4, not H2SO4 solution. Now, let's think about this mathematically. We're going to multiply the numbers, obviously, right? But let's think about the units. If I'm multiplying H2SO4 solution as a numerator to this, and here it's in a denominator, it's kind of the same thing as if we were doing a bridge notation. This right here, liters of H2SO4 solution, is going to cancel this liters of H2SO4 solution here, right? So when we multiply those two together, what's our unit going to be at the end? What's our unit at the end? What do you guys think?
Grams?
Not gram. Well, at the very end, it's going to be grams, right? That's what we want. But at the end of this calculation right here, what are we going to finish with?
Oh, moles?
Moles, exactly, moles, right? Because the liters part has canceled out. Now, this right here is just what the M stands for, right? The M stands for moles of solute over liter of solution. I just replaced that M with actual moles of solute and liters of solution. So the liters of solution here cancels out because this liters of solution here is the same as if it were over 1, right? And then when you multiply two fractions together, you multiply the top times the top, bottom times the bottom. If there's something on the top that matches with the bottom, you can cancel that out, okay? So here we have 0.33362 times 9.168, right? Multiply those two together, and what do you get? 3.05. And I'm going to go ahead and write it over here so that I have space on the bottom here. 3.0586. I think that's enough. 86. And that's going to be moles of H2SO4. So that's what we have right now. Okay. Does this make sense so far where we're at? That was step 2. Now,
yes.
What is the final step? What do you guys think? What would be the final step?
Multiplying by the molar mass.
Exactly, right? We know the moles of H2SO4. Are we dealing with the solution anymore?
Oh.
No, right? We're not dealing with solution anymore. This H2SO4 doesn't stand for solution. It stands for solute, okay? It's the actual solute, all right? So the actual powder that got dissolved, okay, into the water, okay, that created the acid. Okay, so here we have moles of H2SO4, and let's just go ahead, and we know exactly how to do this. This is not a difficult thing that we have to do. We have, and I think we may get cut off in about 5 minutes if we're not careful. So we have 3.0586 moles of H2SO4 over 1. And how do we get the grams? We have to use what? The most important thing in chemistry.
Periodic table.
Periodic table, exactly. Now, what you could do is you could be an incredible working student, right? And you can figure that out, or you could just ask Siri, what is the molar mass of H2SO4? Hey Siri, what's the molar mass of H2SO4?
Okay, I found this on the web for what's the molar mass.
Figure out.
Want to do shadow though, because
So sulfuric acid, which is H2SO4, is 98.8 grams per mole. Okay. So let's go ahead and write that out. 98.08 grams of H2SO4 per 1 mole of H2SO4. And all that does is add 2 H's, 1 sulfur, and 4 oxygens. And that's going to be your molar mass of H2SO4. You guys can double check it. I'm not going to double check it. If it's not right, I can actually just figure it out right now because the problem did it for me. Yeah, okay, that is the molar mass. Okay. In fact, we can go one more and put 86. Okay, grams of H2SO4. Okay, how do we solve this now? We have mole on the top, mole on the bottom. We're gonna finish with grams, right, of H2SO4, which is what we want. And we're gonna multiply this, okay? And we have 3.0586 times 98.086. And then your final answer is going to be 300. Oh, I think I made a mistake. Where was my mistake here? I made a mistake somewhere here, because it's impossible that you'll have, I think, 300 grams in the solution. Wait, if you have 50, yeah, you can't have 300 grams of H2SO4 in a 50-gram solution, right? So I made a mistake here somewhere, and that's right here. It is not 3.0586 moles. What I did here, let's go ahead and let's rewrite that. 0.33362 times 9.168, and I'm still getting the same thing. So I messed up here. Oh, I think I didn't divide by 1,000 here. All right, sorry. Let me just double check this really fast. And there we go. That's the problem. Okay. So what I did, what happened, the problem was that here, when I did this operation here, I got 0.3362, but the actual answer was 0.03362. 0.0, okay? And that doesn't change anything except for the fact that now you're just moving the decimal point over, okay? So the decimal point is not there, decimal point is there, which means that this is not what we're using, okay? I divided by 100 instead of by 1,000. This decimal point is actually supposed to be right here. So 3, let me just try to fix that, 5, 8, 6. So 0.3586, let's go ahead and finish that. 0.30586 times 98.086. And there we go. So here now we get 30.0000 grams. Let's figure out how many significant digits can my final answer have. How do we figure that out? What do we have to look at? What do we have to look at to figure out how many significant digits our final answer can have?
At the beginning.
The very beginning, right? How many significant digits are there here?
3.
3. So how many can I have here?
3.
Just 3. So are we done?
Perfect.
There we go. Final answer. Okay, I know this was probably the longest thing that we've ever done in this class, but it wasn't supposed to be that long. We made a mistake somewhere in there, and also I was trying to explain like a bunch of stuff. It's tough, right? Because I haven't given you any background on this stuff. Okay, so I had to explain every single step.